In the last section, we converted from moles to grams, and now we'll just do the opposite. We'll go grams to moles, mass to moles. So now in my scenario, I have iron being exposed to air where it undergoes corrosion to form rust. Rust is iron 3 oxide. How many moles of iron 3 oxide are contained in 92.2 grams of pure iron oxide? Okay, so in a nutshell, this is what I'm thinking about in my head. I'm thinking about starting with whatever number I'm given. I was given 92.2 grams of iron oxide. And I'm thinking about setting up a proportion where the unit that I have is going on the bottom and the unit that I want is going on the top. The question says how many moles? I want it in moles. So it's kind of the opposite of the last calculation we did, but I don't try to memorize this mole roadmap, or I don't try to memorize when I switch from this to this, you multiply, this to this, you divide. Just set it up. I'm obsessed with setting it up with units that cancel. So I wanted grams on the bottom, I want moles on the top. Now anytime you see grams, it comes off your periodic table. If it's a compound, I gotta add it up. So I gotta do a little sidebar here to find the mass of the iron oxide. So I'm thinking in my head, iron is 55.8, I'm gonna say 5 grams per mole. And there will be 2 moles of iron atoms for every mole of iron oxide molecules. And oxygen's mass is about 16 grams per mole. And there will be 3 moles of oxygen atoms for every 1 mole of iron oxide. There. I'm going to plug that in my calculator, add it up, and I've got the molar mass. 55.85 times 2 plus 16 times 3. Yeah, I got it. I'm really close to the same molar mass that they had. I'm looking at about 159.70. They've got about 159.6. I'm totally fine with that. Periodic tables are all a little bit different. They might give a little bit different decimal spots. We might round them a little differently. So if you were comparing notes with a buddy and somebody had 159.6, 159.7, they are both A-okay. So I put that number in for the mass, and the molar mass is always the mass of 1 mole. So anytime you set up these conversion factors on your proportion, when you see the unit mole, it's always going to be the number 1. When you see the unit grams, it's always off the periodic table. I might just have to add it up if it's a compound. And then I'm in business. I see that my grams on the top will cancel with my grams on the bottom. In my calculator, I'm going to multiply the numbers across the top and divide by anything on the bottom. Obviously, I don't have to multiply by 1. 92.2 divided by 159.7. Sure enough, I get about 0.577. They got about 0.578. Looks good to me. So in the end, we had like the same setup. I just don't think about it as so much work and so many steps. I just focus on getting that proportion, getting those units in there right. Now, does this answer make sense? Well, I suppose. I've got about 92 grams. It's a little less than 100. Each mole would be about 160-ish. So, yeah, it makes sense that like 92 is a little bit more than half. Yeah, that makes sense. Our answer is reasonable. So let's try it again. All right, so let's set this up. Calculate the number of moles in 75 grams of dinitrogen trioxide. Oh, look at all these formulas, these compounds, blast from the past. So I start with my number, 75 grams. Got to put the unit in. And what is it? It's covalent this time. Whenever you see that mono-di-tri stuff, it's a covalent compound. Electrons are shared. And so since I don't have any charges, the prefixes will tell me the ratio. Dinitrogen trioxide, N2O3. Alrighty, I set up my proportion. I do not want my answer in grams. The unit that I want is moles. Whenever I see moles on a proportion, I know it's going to be a 1. And whenever I see grams, I'm going to add it up on my periodic table. So I'm going to say nitrogen is about 14.01 grams per mole. And there will be 2 moles of nitrogen atoms for every mole of a dinitrogen trioxide. Oxygen is about 16 grams per mole times 3. There we go. We add it up, and then it's going in my proportion. 14.01 times 2 plus 16 times 3. Fantastic. I'm getting about 76.02 grams per mole, and that goes in my proportion. Then what does grams per mole mean? It means that it is the mass of 1 mole. I love it. So I got her set up right. I got grams on the top. It'll cancel with grams on the bottom. I can multiply across the top and divide on the bottom. But again, I'm not really going to multiply by 1. I'm going to say 75 divided by 76.02. Bingo. This is great. So my first number had 3 digits, 75.0. So I'm just going to round this to 3. 0.987. And now that's in moles of N2O3. And so for rounding, just go back to the number of digits in the original given number. If I was given 3 digits, leave 3. And now can I see if this is reasonable? Absolutely. Every mole is about 76 grams. I've got 75 grams. So yeah, I should have a little bit less than a mole.